Formation of covalent bond. After understanding all the properties which are associated with the covalent bonds, the types of the covalent bonds like polar and non-polar, let us now move to the most important part, the formation of covalent bonds. See, many people try to explain this, how the covalent bonds, how the bonds are formed from the very early of the 20th century. But it was the first credit goes to the Hitler in London, who gave the theory called valence bond theory. In short, we call it VBT. This was given by Hitler in London in 1927, and they explained the formation of a diatomic molecule, covalent bonded molecule. And they were the first one who not only explained the formation, how they are formed, they explained it energy-wise also. Now we can take the main important features of this theory by considering the examples of a hydrogen molecule. Now what they did is they tried to bring the two hydrogen atoms close to each other from a very large distance. This is the internuclear axis, the axis which is formed by joining the nucleus of the two hydrogen atoms. This is one hydrogen atom, this is one hydrogen atom. These are the two electrons they are having. Now when they were having a very large distance between them, there is no interaction. The graph can be plotted like this to understand their nature, how these bonds are formed. This is almost is your internuclear axis, this one. So we can take along this internuclear axis, actually we are doing is what, internuclear distance, and on the y-axis we are taking what, energy. Now what we find is the graph of this formation of a hydrogen molecule comes out to be like this. Now this is, see, when the distance is very large, we were having no interaction between the two hydrogen atoms. It's fine. As we are trying to bring them closer to each other, what we find is till certain distance, no energy change takes place. But beyond a certain point, what we find is when they are trying to come very close to each other, what happens is we find that the energy starts decreasing. We are coming from this side. Why it is start getting decreasing? The reason is because these electrons are not only being attracted by their own nucleus, by the nucleus of the other atoms also. Like this. So there are more stronger electrostatic forces of attraction which are developing between them. Of course, there are repulsive forces also, but these interelectronic repulsion and internuclear repulsion, but these are the attractive forces are more stronger, and that's why, since these stronger forces are formed, energy is released, and that's why the energy of the two hydrogen atoms is decreasing. We just bring them still more closer to each other. This is the internuclear axis. And we were trying to find out that till what point we can have this decrease in the energy continuing. We find that they reaches to this point almost at the just lowest or bottom point of this graph. Now this is the point at which what we find is these two hydrogen atoms are having least energy, and this means that the forces between these electrons in the nucleus are now the strongest. And we say that this is the point where you can find out the distance. This is the point where the bond is formed. So this is why this bond is formed, because at this point energy of the system is minimum, the distance of the two hydrogen atoms is very less. We can also find out what exactly this distance is. This distance comes out to be 74 picometer. Whereas we know the radius of hydrogen atom is 53 picometer. It means what? If they are just touching each other, then the radius would have been what? The distance between the two nuclei would have been 106 picometer. Then why it is 74 picometer? It shows that the overlapping of the orbitals, atomic orbitals, is taking place. These electrons are now mutually shared, and the bond is what is the electrostatic forces of attraction between the electrons and the nucleus. This situation is called the bond is formed. Now we still try to bring them more closer to each other. Then what we find is we are still decreasing the distance. The energy of the system increases, it shoots up. The reason is now the repulsive forces between nucleus and nucleus and the electrons and electrons become very stronger than the attractive forces, so energy increases. So we can have system up to at this point only. So by taking this example, they not only explained how the bonds are formed, but they also explained energy-wise how they are attaining stability because the energy is released. Remember, the energy is released, whatever the energy is released in this system is called the bond energy. The same amount of energy will be required to break this hydrogen molecule to the individual atoms, which we have already studied, and that is also called bond enthalpy.